Have you ever wondered how computer science, the field that has revolutionized our world, came to be? Our story begins in the early 19th century with a man named Charles Babbage. Babbage, often referred to as the father of computing, conceived the idea of a mechanical computer, which he called the analytical engine. This engine, although never fully constructed during his lifetime, was designed to be programmable to carry out any calculation or sequence of operations. It was a monumental leap in thinking, laying the groundwork for the computers we use today. Alongside Babbage was Ada Lovelace, an incredibly talented mathematician who recognized the full potential of the analytical engine. She saw beyond its immediate application for calculations and envisioned the possibility of the engine manipulating any content that could be represented in digital form, such as music and art. This made her the first to consider the concept of a machine that could manipulate symbols in accordance with rules, and is why she is often considered the world's first computer programmer. These early innovations, the analytical engine and Lovelace's programming ideas, were fundamental in the birth of computer science. Babbage's machine was a physical manifestation of abstract ideas about computation and data manipulation. It was a machine that, in theory, could be used to solve any mathematical problem. Similarly, Lovelace's understanding of the machine's potential uses was a critical step in moving beyond numerical calculations to more complex computational tasks. These early seeds were planted in a time when the world was powered by steam and industry, and the idea of a programmable machine was almost unimaginable. Yet, these ideas took root and formed the basis of a field that would, in time, revolutionize every aspect of our lives. So, the seeds of computer science were planted in the 19th century, but it was during the 20th century that these seeds would truly sprout. The 20th century brought with it a wave of technological advances, and at the forefront of this wave was the evolution of computer science. As we journey into the 1940s and 1950s, we find ourselves in the heart of a technological renaissance. It was in this era that the first electronic computers were born. They were behemoths, filling entire rooms with their complex circuitry and miles of wiring. One of the first of these electronic giants was the Electronic Numerical Integrator and Computer, or ENIAC for short. Born out of the necessity of World War II, ENIAC was a marvel of its time, capable of solving complex artillery trajectory calculations in a fraction of the time it would take a human. Hot on ENIAC's heels came the Universal Automatic Computer, or UNIVAC. UNIVAC took the world by storm, becoming the first computer to be produced in quantity and sold commercially. This machine, with its magnetic tape storage and ability to process both numerical and alphabetical data, was a glimpse of what was to come. But what good is a computer without a language to communicate with it? The mid-20th century also saw the creation of the first programming languages. Fortran, or formula translation, was one of the first. It was designed by IBM in the 1950s for scientific and engineering calculations. Not far behind came COBOL, or Common Business-Oriented Language. Unlike Fortran, COBOL was designed with business data processing in mind. It was the first programming language to incorporate English-like syntax, making it easier for people without a scientific background to use. These early computers and programming languages were more than just technological achievements. They were the harbingers of a new era. An era where information could be processed at unprecedented speeds, where complex calculations could be completed in mere seconds, where data could be stored and retrieved with ease. These early computers and programming languages set the stage for the digital revolution that was about to unfold. As we moved into the latter half of the 20th century, computer science began to reshape society in a myriad of ways. The development of the personal computer was a game changer. This revolutionary piece of technology transformed computers from room-sized monoliths accessible only to a select few into compact devices that anyone could use. The pioneering work of two individuals stands out in this era: Bill Gates and Steve Jobs. Gates, the co-founder of Microsoft, saw the potential of personal computers and set out to place one in every home. He achieved this through the creation of user-friendly software that made computing accessible to the masses. Meanwhile, Jobs, the co-founder of Apple, focused on the intersection of technology and design, creating products that were not just functional, but also aesthetically pleasing. While personal computers were making their way into homes, another equally groundbreaking development was taking place: the creation of the internet. The internet democratized information, making it widely accessible and forever changing how we communicate, work, and live. Just as the hardware was evolving, so too were the languages used to instruct these machines. The rise of modern programming languages made computers more versatile and powerful. Languages like C++, Java, and Python allowed for greater complexity in programming, giving birth to applications that were previously unimaginable. These developments didn't just change technology, they changed us. They transformed how we interacted with the world and with each other. They gave birth to new industries and jobs, reshaped economies, and redefined what was possible. As the 20th century drew to a close, the digital revolution was in full swing. The personal computer and the internet had become integral parts of our lives. New programming languages were enabling us to push the boundaries of what technology could do. By the turn of the 21st century, computer science had firmly entrenched itself in virtually every aspect of our lives. Today, computer science continues to evolve at a breathtaking pace. As we speak, artificial intelligence, or AI, is reshaping industries and redefining the boundaries of what's possible. We're now seeing machines capable of learning and making decisions, a concept that was once purely science fiction. AI algorithms are enhancing healthcare, powering autonomous vehicles, and even generating art. But this is just the tip of the iceberg. The field of AI is expanding, and its potential is vast. Machine learning, a subset of AI, is another fascinating area of computer science. It's the process that enables computers to learn from and make decisions based on data. Essentially, we're teaching computers to learn much like humans do, and that's a powerful tool. It's machine learning that's behind the recommendation systems of your favorite streaming services, or the predictive text on your smartphone. In parallel, quantum computing, a field that harnesses the peculiarities of quantum mechanics to process information in ways that traditional computers can't, is gaining momentum. While still in its infancy, quantum computing could one day solve problems that are currently beyond our reach. And then, there's the realm of virtual and augmented reality. These technologies are transforming the way we interact with digital content, bridging the gap between the physical and digital world. Imagine being able to step inside a computer-generated environment or overlay digital information onto your everyday surroundings. Looking ahead, the future of computer science is bright and brimming with potential. We might see the rise of sentient AI, computers that can understand and interact with us on a deeper level. Or maybe we'll see the development of truly immersive virtual worlds, or quantum computers that can crack the most complex codes in the blink of an eye. Only time will tell where computer science will take us next, but one thing is clear: its impact on our world is undeniable. So, how did we get from Charles Babbage's analytical engine to today's world of AI and machine learning? It's certainly been a fascinating journey, marked by remarkable innovations and the sheer power of human intellect. Our story starts in the 19th century, with the visionary Charles Babbage and his collaborator Ada Lovelace. Babbage, often referred to as the father of the computer, conceived the idea of the analytical engine, a mechanical general-purpose computer. Lovelace, on the other hand, is celebrated as the world's first computer programmer. She saw beyond the engine's arithmetic capabilities, envisioning its potential for creating any kind of content, including music and art, a concept that was far ahead of her time. Fast forward to the 20th century, a period that marked the birth of modern computing. This era brought us the first programmable computers like the ENIAC and the UNIVAC, setting the stage for the digital age. It was also during this time that the foundation of modern computer science was laid, with the development of algorithms and data structures, and the introduction of programming languages. Then came the digital revolution, an era that saw the rise of personal computers, the internet, and mobile technology. This period democratized access to computing power, bringing it into the hands of everyday people. It also marked the beginning of a new era of information and communication, reshaping society in ways that were unimaginable just a few decades earlier. Today, we're standing at the frontier of an exciting future. Artificial intelligence, machine learning, quantum computing, these are not just buzzwords, but real technologies that are poised to revolutionize the world as we know it. And as we look ahead, the role of computer science in shaping this future cannot be overstated. In the span of just 2 centuries, computer science has transformed from a theoretical concept to a force that shapes every aspect of our daily lives. It's a journey that is as fascinating as it is profound.